Hello, hello, hello. How's everybody doing? Welcome back to the CP103 104 review session for this week. My name's Steven. If you guys don't already know me, I'm a third year BBA computer science student here at Laurier, and I'm joined with my wonderful co-hosts. If they like to introduce themselves now, and we can get started with Noah. So go ahead, Noah.
Good
Good
evening,
evening,
everybody.
everybody.
My
My
name's
name's
Noah.
Noah.
Hey, my name is Mila.
Okay, so we can just get started. Noah, you can take it away.
Sounds like a plan. Um, Sorry. So yeah, welcome everybody to the review session. Um, Please, if you could just take a moment to sign in with the QR code, um, that would be great. I'll give you guys some time to do that, I guess.
Yeah, we'll leave it up for about a minute or two. Everybody sign in. It'll go on your experience record. Jacob is sending that in chat right now. So if you can't scan the QR code for some reason, just go into chat. There's a link there for you. And for anybody that joins late, we can just have this at the end of the stream as well. If anybody needs it, we'll pull it back up.
All right, perfect. So yeah, our upcoming events, we have the project program React 101 workshop, which is on Wednesday, November the 2nd, and our next review session, which will be on Thursday, October 27th. Um, so yeah, and on the agenda today, these are the key topics that we'll be covering. So number one, functions, their use, what parameters are and what return statements are regarding functions. Two, we'll be looking at importing functions. Three, we'll be looking at the function checklist. Four, we'll be looking at testing. We'll be looking at if structures. And in five, we'll be looking more at return statements.
Okay, so to start, we're going to talk a little bit about doc strings. So a doc string, simply put, is just a block of comment that you put right after you write your function, you put it right before that. And it has three different components. So the first component we normally put is use, and it just explains how you would call the function. Parameters is explaining what is going to be true in order for the function to work correctly. So it's your inputs. And returns are going to explain what the function will do if the parameters are all correct. So function documentation must have the use and returns, but sometimes it may not have anything for parameters, and that's simply just because not all functions require parameters. It just it depends.
Sorry about that, guys. I was muted there. I didn't even notice, but we're back. Okay, so let's just do a really quick example. So we have a function here called calc angles. As we see, there are three parameters: side A, side B, and side C. And how we like to format these doc strings are with these separators, just so we as the users have a more readable comment, so we really understand what's going on. So this function would calculate the angles of a triangle given the lengths of its sides. And so here we have the use case. So we can say angle A, B, C equals calc angles of side A, side B, and side C. And obviously we have the parameters side A, side B, side C. And we just have a side C, just some extra documentation. It's going to be less than side A plus side B, just because that's how triangles are. And then it returns angle A, angle B, and angle C in radians. As well as we have the parameter types as well as the return types. So in this case, they would all be floats because we could be dealing with decimals as we looked at in our last review session. So I'll pass it back off to Mila and we can go through some more about functions.
Perfect. Thank you, Stephen. There we go. So quickly, we're just going to talk a little bit about importing functions. So functions can be imported from a file in the same directory. So an example of this would be when you guys make your testing files. So you would say at the top of your testing file, you would say from functions, if that's the name, import whichever function you'd like to import. And then functions can also be imported from external files. So for example, a library. In this example here, we're saying from the math library, import the function add. And then we have a quick little function checklist for you guys. So just some notes, make sure that when you're writing your functions, you're giving them a valid name and make sure that they're unique. We can't have the same function names or else you're going to get some errors. So when calling a function, make sure the number of arguments match the number of parameters. Make sure everything, you got all your parameters set. Make sure the argument types match the parameter types exactly, and then make sure to get any return value. So, you simply put the return value or the variable that you're going to return it to equals, and then call your function. And then obviously if a function doesn't have a return, you wouldn't write that part. But yeah.
Okay, so let's go through an interactive example. We're going to go through kind of all of the steps of writing a function, its docstring, and importing and calling the function. So we're going to make a really simple function, just calculating the area of a rectangle using its length and width, and using one return statement, and then calling the function in a separate file. So let's get started with that. If anybody wants to use this, it's a website called Replit. It's kind of like little Python IDE. Actually, you can use it for more than just Python, but it's really useful when you don't want to create like a whole new file on your PC. You can just do everything online. Okay, so let's get started. We can call our function. We use the define keyword to begin our function definition. So let's call it function area underscore rec. And then we know because of the function definition or the question that we want a length parameter. So let's say length and a width parameter. So we can begin the function definition with a colon, but before we do that, let's create our docstring. So for a docstring, as we learned in our last review session with string formatting, we know that triple quotes means that a string can take up more than one line, which is going to be necessary here because our docstrings are more than one line just in nature. Okay. So let's begin with a function description. So let's say calculates. Sorry if I make any spelling errors. I'm just trying to type fast just so everybody just gets the idea of what's going on here. Okay, calculates the area of a rectangle using its length and width. All right, so now let's create our use statement. So this is pretty much how a user can call the function. So our area rectangle, we know that we want to return an area variable or data about the area of the rectangle. So let's call the return area equals area underscore rec length and width. So in every case, this is how we would call the function. So area equals area of a rectangle, calling a length and a width variable along with that. Okay, so let's just add some dashes here just so we can separate kind of the use case and the description from the parameters and the returns. So let's start off parameters. So here we know that we get a length and a width given to us. So we can say length is a length of the rectangle, and it's going to be a float of course, it's going to be over 0. So that's just a good description of what this is going to be. So whoever's using this won't really have too much confusion about what they're going to be inputting into this function. So we know that it's a float, meaning a decimal number, because obviously we can have a length or a width in that case. So we can just say the same thing actually for width. Both of these can have decimal values. Let's say a rectangle with a width of 4.5 centimeters. It's not just limited to 5 centimeters, which would make it an int. So let's say that's above 0 as well. So those are only 2 parameters for this. And we can say returns. We only have one return in this case. Let's call it area. It's going to be the area of the rectangle. And this as well is going to be a float above 0 because we know that both of our length and widths are going to be floats above 0. So obviously our area is going to be greater than 0. Okay, so now that we've defined that, we've defined kind of what our function does, the use case, parameters and returns, we can go on now to actually putting some code into our function so it does something and it's not just a block of text. All right, so this is a very, very simple function. We all know that the area of a rectangle is just equal to length times width. All right, so now that we have that, we can see a little yellow underline just because we aren't doing anything with this variable. So that's just an error that we get. So then after that, we can say return area. All right, so now what this is saying is we're taking the length parameter, which we're getting in the function, multiplying it by the width parameter, which is also given to the function, storing that data in a new variable, which we're calling area, and returning that area. All right, so now that we have this, we can call this perfectly fine from here. So we can say area rec, let's say of 5 and 4. So we all know, so let's follow the use case actually. Area equals area rec 5 and 4. So then we can say print area just so we know what's going on here. And let's run this really quick. Okay, there's something wrong with one of the other. All right, that's weird. Sorry about that. Just give me a second. Let's just comment all of this out. All right, that's fine for now. All right, so let's run this. Just give it a second. The first time you run a replit, it's going to take a little second. I don't know what's not running. Well, okay, so what this should return is obviously 20, as we know. Not sure why it's not running. That's weird. Oh, okay, I see. My bad. Sorry about that, guys. It's just running everything that's in the main.py. I should know this. Okay, there we go. So now the replit's just kind of weird like that. But as we see here, we can see that we're just calling the function using its use case, and we're printing the result, which is obviously 20 because we're just multiplying 5 times 4. So yeah, exactly. Jacob's saying it's from the replit, not from the function itself. The function is written correctly, it's just the replit. So we have it here, but we also have it in this main.py. What if I want to have a testing file, but I don't want to write the entire function in the testing file? So what I can do here is import the function because these are both in the same directory. So we can say from function, which is the name of the file that we put the function in originally, import, what do we call it? Area underscore rec. So what this does is it takes from the file function, it imports the function area underscore rec. So this is essentially like we already wrote the function into this file. So we can call it the same exact way. So we can say area equals area underscore rec 45, and let's print area like we did before, and run that. And there we go. It's printing 20 twice. I guess it's just running it again from the previous time. But if you take my word for it, Replis being a little bit weird today. But so we're importing the function from the function.py file, and then we're just calling it like we would if the function was already in here. So that is good. All right, so let's get back to our slides. So that's pretty much the basic way that you're gonna run through creating functions and importing them and calling them. So in your labs and assignments, I believe you're always given the doc strings. So you can just copy that into your big functions.py file and then import them into your testing. I believe in the midterm, you're not given doc strings. So it's good to practice kind of writing them and knowing what's in them. So obviously the use, which they care most about the use, parameters, and returns, just because that is what is going to give the user the most information in the least amount of space. So I'll give it back to Mila and we'll get back to the slides.
And by Mila, I think he meant Noah because that is my name. But okay, so yeah, for testing and specifically with if structures as a way of doing your testing. So just in general, testing is something key to writing good code. If you don't test your code, it's probably not going to work. That's the honest truth, because code's probably not going to work the first time you do it, unless you're incredibly lucky. So testing programs with if statements involves determining what the exception paths through the program are and what testing each of them in turn is. So that might sound a bit like daunting, but I'll just explain in more simple ideas. So let's say you have a function and you're passing to it an integer. So an integer can either be positive, which means greater than 0, negative, which means less than 0, or it can be 0 itself, which is neither positive nor negative, right? So let's say you, when passing in the function, you're going to be making comparisons, say if it's greater than 0, if it's less than 0, or an else case, or you could say if it's equal to 0, but you already know that it's not going to be something that's not greater than 0 and less, so something that is not greater than 0 and not less than 0, and then also not equal to 0. That's just not possible with integers. So yeah, you could like make a function like that, and then if you're comparing through it with if statements under each case in the ifs, you could do like print greater than 0 or print lesser than 0 or print equal to 0. That's just like an example of how if statements can be really, really helpful just for like making little tests in your code, because like it's just the only way. It's a really good way for you to know like where almost you're navigating in the code almost. If like a certain block is maybe not being like reached at all, then because a certain print, and you'll know because a certain print statement is not being outputted. So it's a really like helpful indicator when writing code. And we also have an example for you guys of that.
Yeah, so let's take a look at an example using if statements. Okay, so this is an example for later on, but let's keep that here. So let's look at this really quick. So we have a function called find age group, which takes in a parameter of an integer greater than or equal to 0, and returns a string called a group that is the age group you belong in. So as we see here, we're just initializing the group variable. And so we're saying if age is less than 4, return toddler, or group is equal to toddler. Elif, which means else if. So if this doesn't execute, that will trigger the else clause. But if this does execute, it's just going to not even go through any of this. So it'll make your code a little bit more efficient. So elif age is less than 6, you are a preschooler. Elif age is less than 8, you are an elementary schooler. Elif age is less than 13, you are a tween. Elif age is less than 20, you're a teenager. And else, if you're anything above 20, you're an adult. And then we just return the group. So let's copy this into our main function so that Replit will actually run it for us. All right, so let's run this. And Oh, sorry, I forgot to go through how we used it. So we're saying group equals find age group 4. So as we see here, this if statement is only checking if we are below the age of 4. So this would return preschooler because we are equal to 4 in this case. And for 6, it would return elementary schooler. So let's say we put this to 25 and run the else exception. It would return preschooler and adult. So another thing you can do with if statements, it's not just limited to less than or greater than. We can also do less than or equal to 4. So if we change the code to this case, we can say, we can run this again and it'll change to toddler because this if statement is now checking if it is less than or equal to, which in this case it is equal to 4. So this line of code will fire. So that's just kind of how if statements work. Thing to keep in mind, a really good, sorry, I'm just struggling with words here, but a really good thing to keep in mind, regardless of what it's called, is the if, elif, or else kind of hierarchy of how if statements work. So first and foremost, you want to use if first. So if something, and then return or do something, okay? And then if this doesn't fire and you have multiple clauses, if you only have 2 clauses, you can just go straight to the else, do something else, okay? So in that case, if you only have 2, so let's say if x is greater than 0 or if x is less than or equal to 0, you can just say if else in that case. But as Noah was saying, if x is greater than 0, do something, and then we can say, actually, let's just write that here. So if x is greater than 0, do something. Elif, so else meaning we know that x is not greater than 0, but we want to make sure it's not equal to 0. We can say elif x is less than 0, do something else. And then either we can say elif again x equals 0, do something. And then we can say else, do something. So here we're checking if x is greater than 0, we do something. If x is less than 0, we do something else. And then if x is equal to 0, we're doing another thing. But here we can check for if x isn't a number whatsoever. So let's say we want our function to only take in integers, but somebody inputs a string, for example. This else clause can make sure that no errors arise. So let's do something really quick here. So let's say add underscore nums, and we just have x and y. So let's not write a doc string for this, just because for the sake of time. But we know that our parameters are x and y. Actually, let's just say here, just for this example, we can say that our only constraint is that our parameters must be floats or x, float, int. That's it. So it's just, they're either floats or integers. That's all that really matters. Or actually, we can just say just float. Won't make a difference. Okay. So we want this function to add, let's say, and then let's just also put a return. Returns, let's say sum equals, and is also a float. Okay, so we can just say sum equals x plus y, and then return sum. So very similar to the first function that we wrote. And so if we call this function sum equals add underscore nums of, like, let's say 1 and 2, and then we go print sum. So this is going to execute perfectly fine. As we know, 1 and 2 can be added together with no problem. So 1.5 plus 2.5, for example, let's say, is going to return 4.0 because 1.5 plus 2.5 is 4. So let's say, for example, somebody messes up and doesn't read our doc string. We can say they enter a string instead. So let's say they enter string. It's going to give us an error because we can't add a string, and a number. So in this case, we can do something called error prevention. So we can say if x is x and y, x is greater than 0, or let's say actually x is greater than 0 and y, or y is greater than 0. Okay, so this actually brings me to another another good thing to look at with if statements. So there are keywords called and or in Python. So we can say and obviously means both clauses or multiple clauses all have to be true for the if statement to go off, and or means only one of them has to go off. So here we can say if x is greater than 0 or y is greater than 0, or y is less than 0 or x is less than 0 or x is equal to 0 or y is equal to 0, then we can run this. So this is pretty much checking every single clause that we were talking about before. So if x is greater than 0, that's good for us because we know it's a number and we know it's greater than 0. Or y is greater than 0. Okay, so that's going to do that. But another thing we can do is we can check if type of x is equal to int, I believe, or type of y is equal to int, or let's say float actually, because that's what we were saying before. And then, so then after this, we can check else we can say print provided parameters are not the correct type. Okay. Oh, that's weird. Okay, well, I don't have really. We're kind of running short on time at the moment. I think I've used up too much in this example, anyways. But my point still stands. If and else or if and elif are great for checking your code. So let's say if x is greater than 0, for example, then we can say, let's call this add subtract nums. So if x is greater than 0. We can do sum equals x minus y. And then elif x is less than 0, we can do sum equals x plus y. And then else sum equals 0, for example. So then we can say 2.5. So this kind of changes what the function does, but we can see how these work. And so here, if we do this, I believe this will return an error because we're not returning anything. So let's say return sum. So in this case, it's going to be -1 since x is greater than 0. We just say 1.5 minus 2.5. And then if we say x is less than 0, we can say -1 in this case. And then it'll return 1.5 since we're doing -1.5 plus 2.5. And then we can say else if x is equal to 0, it'll just equal 0. So that's kind of how if statements work in Python, and they're a very, very valuable tool, not only in testing, but in decisions, if you want to test whether one thing is happening or another thing is happening, and then performing different tasks based on that. Sorry I took up so much time. I'll pass it back off to Noah, I believe, to continue the rest of the presentation.
Thank you so much, Steven. All right, so yeah, hopefully that example was helpful to you guys. So using return statements correctly, you can use multiple return statements, but it's best to only use one because ultimately it demonstrates that you can write a really good algorithm and it makes debugging easier. So using one return statement as opposed to multiple demonstrates that you can write a really good algorithm because return statements take a lot of memory. So if you're putting a lot of unneeded return statements in your method, in reality, you're just hogging a bunch of like memory that you don't actually need. And so if you can write code that's more efficient that will take less memory from your computer, then in reality it's a more efficient algorithm because it's less resource heavy and it'll also be able to work on more systems that way because computers only get more and more memory as time goes on. So older ones are gonna have less. With a Python program, any like semi-modern computer can probably run Python code, but still, just as a premise, you want to use as little memory as possible to just get the job done. And it also makes debugging easier. The reason for that is when you call upon a function and it returns a value, if you're having multiple returns, then you might be struggling to identify from which return statement it is returning the bad value. Versus if you know there's only one return statement, you don't have to worry about which return statement is returning the bad value. You know there's only one return statement, so just all the code before that return statement must, for some whatever reason, be creating this value that when we return, it's bad.
All right, cool. So let's look at
Is that an
another.
example?
Yeah.
Yeah.
Let's look at another example using. Okay, let's get this back. Sorry, I had to delete it just because I did not realize Replit only let us use one file to actually execute code. Just give it a second here to come back. Oh, that's not good. Okay, well, looks like we're gonna have to come up with an example on the spot here. Okay, so let's say define area underscore surface area, for example, or actually let's say circumference diameter. Circum diam. Funky name. All right. So all we need is the radius of a circle. So again, with this, let us skip the doc string. And so this is going to give us two important lessons. One of importing and another one of just returning multiple returns and why we shouldn't do it. Okay, so let's just, I keep saying I don't want to write doc strings, but it's a valuable lesson for you guys. Doc strings are extremely, extremely valuable just because they really help you grasp what's going on. If you're really not understanding what a function is supposed to do, writing out a doc string is really going to help you understand. All right, so let's say calculates and returns the circumference and diameter of a circle. Cool. All right, so the use case is going to be circum diam equals so here we are putting two variables because we want to have two returns. We want to calculate the circumference as well as the diameter. So that's important. Okay, let's separate this a little bit just so we can read this a little bit better. Parameters is just going to be radius, which is radius of a circle, float greater than 0, because we do not want to have negative numbers just because it doesn't really conceptually make any sense. So next, let's say the returns. So here we want to have returns circumference of a circle. This as well is going to be a float greater than 0, and diam, which is going to be the diameter of a circle, as well, float greater than 0. All right, so as we all know, the diameter of a circle is equal to radius times 2. And to find the circumference, we need the diameter multiplied by pi. So Python doesn't have just a pi value in it for some reason. So we need to import that. We can obviously say, like in our code, pi equals 3.14, but that won't be very accurate. So what we can do here is from math, import pi. So math is an external library. So from pretty much the math external library, we want to import the pi variable. So here we can say circumference equals diam times pi. So this will give us the exact value of pi. And so here we can either say return diam and then return circum. So this will obviously return both of them, which seems fine, I guess, but why not just have it in one line? There you go, big brain, guys. Diam, and then comma, circum. So we're just like differentiating between the two variables. And so now let's call the function. Let's say circum, as we said before. Oh, actually, so this is another good thing we can take a look at. Diam radius. So either I messed up the use case or I messed up here. As Noah was saying before, this is very good for debugging. So if I were to run this now, it's going to give me the diameter value first and store that in the circumference variable, which isn't going to be very good. And we could see that very, very quickly because if you want to take a look here, diameter came first in this return statement when in the use case circumference is supposed to come first. So we can just switch these around here. And instead of radius, let's say 4. And let's say print circumference and print. All right. So there we go. Here is the circumference of the circle and the diameter of the circle. So it would have done the same thing if we printed it like this, or circumference, sorry, or if we returned it like this, my bad. However, does, oops, my bad. Well, clearly multiple returns are not good, folks. So just use one return and your life will be much, much easier. You'll be able to debug your code better. You'll not look like a noob in front of your friends using multiple returns. And I don't know, you will just be more proficient in Python, not use as much memory as Noah was saying before. So yeah, that's really the purpose of return statements. They're very, very useful. Functions can't really do anything without return statements. Obviously, we can print this out using the function, but that gives the function less functionality. So yeah, return statements are very, very useful. All right, so looks like it's time for a Kahoot. This was everybody's favorite segment. So let's pull that up. Sorry, I didn't have it prepared from beforehand. Oops, wrong thing. Don't want to join one. But this is the website you guys are going to go to, so that's good. So let me just pull this up. Sorry about this, guys. I will give me 1 second to pull this up. All right. Classic mode. All right, all right. Okay. So I'll keep this up for a while. Let me know if you guys can hear the Kahoot music. I know last time I wasn't really able to hear it, which is a bummer, but everybody join up. Sorry, I had to move Mila and Noah's face cams just so we could see the code and the QR code. So Noah, Mila, I don't know how familiar you guys are with the questions. I don't know if it's cheating if you guys join, but like, if you guys want to join, that'll be pretty fun. I guarantee you guys that.
I didn't study though.
It's cool. It's cool. This is for everybody's skill level. It'll just kind of test if you guys were listening. Let's go. Stephen Goat's back. Real one. Real one.
Noah, let's give it a shot.
Why not? Let's do it.
All right, I'll leave this up for like another minute or two just everybody get in here. It's gonna be a great time. All right, one more minute, guys. There's only 8 of you in the Kahoot. There's 16 people in the Twitch stream, so only half. Not a very good, you know. But like, join up, guys. Okie dokie, I think 10 people is good. Leave it up for 5 more seconds. Last call. Anybody wants to join now, or you will miss the opportunity of a lifetime. Okay, so 5, 4, 3, 2, 1. All right, let's get started. So I'm going to read the questions too, just because I think our face cams might be blocking them for future reference. Well done, guys. Well done. All right, let's see who's on top. All right, I'm 26. I think that's Mila. So Mila, do worse, please. Okay, so how would you import a function called add numbers from a file called functions in Python? Well done, well done. Oh, let's go, Mila. Dude. All right. Stephen Go, rising the ranks again. That's what I like to see. All right. So this one's a multi-select answer, so select more than one. Which of the following are invalid function names in Python? So I'll give you guys a hint. Everything that isn't a valid variable name either is also an invalid function name. This might be a little tricky. Well done to those who got it correct. So yeah, let's just go over this a little bit. Stephen Go. Let's go Larry at the top. So function names cannot start with numbers. They cannot start with any symbols, just because that's how Python works. It kind of does code like that. So just keep that in mind. Don't name anything like hashtag something. Obviously hashtags create comments as well. So definitely don't name anything hashtag. Don't name like exclamation point like we saw there. Don't name anything with numbers. Try to keep it to letters is the first one. So yeah. Which of the following operations is not included in Python and must be imported from a library? So this one is a little bit tricky as well. Well done. Well done. So let's just go over these really quickly. Floor division is the double slash in Python that floor divides, or integer division, maybe called. Multiplication, obviously, we know is the asterisk. Exponent is the double asterisk, but square root we have to import from, again, the math library, same library we imported pi from. So it would just be, instead of from math import pi, it would be from math import sqrt, or square root. So next question, let's see who's at the top. Ooh, Larry fell down. Noah, do worse, please. I need somebody else to win. I show CS coming off 4 hot streak. Let's go. 104 GOAT. Kind of looks like you are the 104 GOAT, but like, you got to win this. Steven GOAT, you're still the GOAT in my eyes, regardless if you win or not. Yeah, love you. All right, next question. Where should inputs be placed in a Python file? Well done. Well done. Yeah, so this should be pretty familiar to you guys if you use the template that's given to you in 104. So the file template starts with obviously your name, the date, like all of your information and stuff. And then after that, it starts with hashtag imports, then hashtag constants, and then whatever else is in your file. So imports are at the very top of the file. So yeah, just so they're executed first. That's very important. So let's see who's at the top. 104 GOAT. Wow, looks like you are the GOAT. I show CS gaining gaining on you though. He's got a hot streak, so watch out for him. Steven GOAT catching up as well. I believe in you guys. So 2 more questions left. How should constants be defined in Python? Well done. So yeah, so as we know, constants should be defined as all capital letters, just so we can differentiate them from normal variables that are prone to changing. So well done, 104 GOAT. You're still on top. I show CS, and Steven GOAT coming in third. So functions have inputs and outputs in Python. What are their proper names? So we went over this a lot in today's session. Well done. It is parameters and returns. So let's see who came on the podium. Third, 5 out of 7. Well done, Steven GOAT. Still the GOAT in my heart. Second, I show CS. Well done. And number 1 is 104 GOAT. Well done. Well done, guys. Guy and GG were runners up. So well done to everybody that participated. So quick little thing, disclaimer. Our next review session is the midterm review session. This is going to be a big thing. It's going to be in person. And to those who are really good at Kahoot, so I'm looking at you, 104 GOAT, I show CS, and Steven GOAT placing on the podium both times. We're going to be having a big Kahoot at that event where there will be room to win prizes. So I believe everybody who places on the podium, this is still to be finalized, but everybody who places on the podium will be eligible to win gift cards. So definitely stay tuned for that and attend that review session. Yeah, so that kind of wraps up our review session. If you guys have any questions, Mila, Noah, and I will be free to answer them. We'll keep the stream on for a couple more minutes if anybody has any questions. They can be, we'll try to keep them like CP104 related. They can be more general comp sci questions if you want. Yeah, whatever you guys want, really. We can keep the stream on for maybe 5 more minutes if there are questions. If not, we can end it here. But Noah, Mila, do you guys have any final remarks?
Nothing for now. But I hope you guys enjoyed the session. You should definitely come out to the next one. It'll be in person.
Yeah, I hope everybody had a good time. I recommend coming to their midterm review session. It's gonna be in person. It's gonna be super fun. I'll be there. So, yeah.
Yeah, so for the midterm review session, similarly to these ones, we'll be going over kind of midterm format, midterm kind of example questions. We're going to go over basic content as well. And we'll open the floor to anybody who's there to ask questions and we'll answer them. So yeah, definitely stay tuned for that. There's going to be some advertising on the Laurier CS Discords and Instagram so it's going to be on the 27th. Time will be released and room location will be released as well. So stay tuned for that. Doesn't look like any questions are coming in. So I'll leave the floor open for about 30 more seconds. Yeah, so like Jacob said as well, just before we do end off the stream, the review session will be in person, but obviously we'd like to have it accessible to as many people as possible. So we're going to stream it on Twitch as well to those who want to tune in online. And we're going to be creating kind of a bank of example questions that are heavily based on previous midterms and assessments. So we hope to see all of you guys there. Yes. Huncho said 104 is hard. Yeah, it can be hard at times, but I promise if you understand the concepts at their core, you'll do fine on the midterm and the final exams. So yeah. All right. Anybody else have any more questions? I will give you guys 10 more seconds to type them in chat. If not, we'll end off the stream now. I hope you guys had a great time here. Hope to see you guys all at the midterm review session and our following review sessions for the year. And yeah, you guys are a great crowd. Thank you so much. Bye-bye, guys. Have a good one.